The central limit theorem gives us a lot of purchase in defining the random error introduced by sampling. But the problem is that the central limit theorem only applies to samples which are randomly collected. Not all samples are truly randomly selected. Maybe none are. Abraham Wald was a Hungarian mathematician who escaped the Nazi persecution of the Jews and came to the United States. He got a position at Columbia University, where he worked on a statistical research group that applied statistical skills to the war effort. His most famous work dealt with the distribution of damage to aircraft which returned after flying missions over Europe. Wald found that the damage aircraft received from the enemy was not randomly distributed. It looked something like this. The Navy had limited resources and asked which areas of the plane should be reinforced if the goal was to help more aircraft survive their missions. Where would you recommend they put the additional armor? The Navy thought they should reinforce those areas on the planes which receive the most damage, where there are the most red dots. But Wald advised they do the exact opposite. He proposed that they reinforce the area where the planes were unscathed. It seemed counterintuitive, but Wald was right. These data came from planes that returned from their missions. The sample was biased entirely in favor of planes that were not shot down. It must be because the planes were shot in the places that are shown, rather than the places that were undamaged. The central limit theorem is a tremendous gift from our mathematically defined universe, but it is not so powerful that we can let our guard down. If you apply it to a biased sample, you'll get a biased result. You still have to watch out for those demons wreaking havoc with our simple minds and putting out the light which illuminates our understanding.